Hey everybody, this is Larry. This is me going over Q4 of the Leetcode contest 278 groups of strings. So this one was a very annoying problem because especially for me, and you can kind of watch me solve it live in the next portion during the contest. And some of the reason why I end up taking about 25 minutes is that 10 of those minutes were me trying to do it in C++, and it's still time limit exceeded. So I got wrong answer, silly mistake on a typo, and then I got time limited fixing that, and then I switched to C++, hoping that wouldn't time limited, but it's still time limited. And then I fixed it by making slightly faster, which is why I'm a little bit peeved at this one, because it's so hard to gauge what is time limited and what isn't, right? And it's not just me. A lot of people, maybe not at the top because survivor bias, but a lot of people have a lot of wrong answers for this one for that reason. So yeah. So for this particular one, remember to hit the like button, subscribe button, join me on Discord. There's a lot of people who likes doing challenge, competitive programming challenge, Leetcode E forums there. So yeah, if that's your jam, come check us out. We're friendly. We don't bite mostly. So yeah. So the thing is that I think one thing that you may kind of get from seeing this problem is connected components, right? I mean, there's even the word connected here and groups and so forth. So your first instinct should have union find or maybe some other thing, but it'll come up to union find for another reason. But these should be the things that you're thinking about. So I got that immediately, and I actually knew how to do it relatively quickly, to be frank. But like I said, TLEs and wrong answers is another story. So here, a second observation is that no letter occurs more than once in any string. So that means that there's some way optimizations that you can do because of that, right? One, for example, is just to represent each word by a Boolean array of 26 characters, or sorry, 26 elements, right? And then converting that Boolean array of 26 elements to a bit mask is what I did. That's basically the idea, and then you can do at least two of these things easily, and then we'll talk about the third in a second. Or maybe in more than a second, but you know what I mean. But yeah, so basically I'll go over my code really quickly for this part. This is just standard union find code. Maybe I should have had this in the template because I feel like I spent, maybe not, I wouldn't say I spent too long writing it per se, but because this particular problem is a little bit complex, it takes me, like, it's distracting, right? Like I want to focus on solving the problem a little bit. But yeah. And then here I have a scene array because one of the inputs is that, and this is something that I did test before, is that you could have multiple of the same input. So yeah, you do have to keep track of how many times each word appears in the input. And I have this one-off thing which I'll talk about a little bit in the future. But yeah. So this is basically, like I said, treat this mask as a Boolean array. Right? Basically, you can think about this as a binary number, right, of this, and you can think about this as A, B, C, D, E, F, G, H, I, J, K, dot, right? And you can think about a 1, meaning that, I mean, I know that it actually, I'm showing this as a least significant least significant bit first, but yeah, for example, 1 here means that the B exists, 1 here means C exists, 1 here means the E exists, and so forth. Yeah, I actually could have some additional optimization anyway, but yeah, so that's basically what I do here, is that I basically put the mask as Boolean array. So it's something that you do have to know for this one, and this basically flips a bit from 0 to 1, and then like I said, I increment the counter. And this is basically step A or step 1 and step 2, adding one letter and minus one letter. So basically my idea is, okay, let's say I have a mask, right? And if it doesn't, if I have a character that doesn't exist in the mask, I add it to the next mask. If it does exist in the mask, I delete it from the mask. And then ignoring this for now, basically, if the one character of word is in the array, or and this is where you optimize it, to all one lookup instead of doing another loop through the array. If this is seen, then we do a union on the union find structure, right? On the disjoint data disjoint disjoint set I don't know, whatever. I'm blanking out for a second, but yeah, basically you do a union here because now you're saying, okay, let's connect. These two things exist and now they know about each other. Let's connect them, right? That's basically the idea of me dancing. That's how I solve problems, and that's basically how you take care of step A and step B. So the other thing that I did get a time limit exceeded on is that I replaced one character of every with any other character. So that means what I did here was that I did my first iteration of the code, and we'll go over this actually very quickly, I suppose. If Leetcode's load, I would go over very quickly. I guess I'm not going over this very quickly. But basically, I just have a for loop that keeps track of every character that's in Word, and then every character that's not in Word. For example, I just do swap from A to B, A to C, A to E, ... right? That's basically the for loop. That time limit is exceeded. So I because that time limit exceeded, I tried to solve in C++. That's still time limit exceeded, so then I had to think about an optimization. And my optimization is this one-off trick. And basically the idea about this one-off trick, I call it one, it's not, I don't know if it's a trick, but it's an idea that I had, and this is just a hash table. And basically the idea I have is that, okay, the idea is that if I remove one character from the original word, then I have this one-off word. That's how I got the name of this variable from. So it's one-off, right? And that means that this this one-off thing is one-off from another word. So that's basically the idea. For example, let's say I have ABCD. Here I brute force, in this case, let's say I start with the A, my one-off word will be BCD, right? Say. And that means that now in the future, maybe BCDE, if I remove the E from BCDE, that would also match this one-off of BCD, right? So basically, it's another way to think about this one-off is kind of you're trying to do a distance of 2 away using add and subtract. So instead of looking at it as a replace, you look at it as an add and then a subtract. And then now this one-off is the thing that they meet in the middle, right? So instead of adding and then subtract, like, you're doing subtracting from 2 words and then see if they match. That's basically the idea here. Basically, and if we haven't had this lookup before, for example, here, if BCD doesn't exist, we cache, basically here we go, okay, one-off of BCD is equal to ABCD, because it's saying, okay, look, in the future, Larry, if you see a BCD, then know that, ABCD is a true one-off thing. So that in the future, when I do BCDE, I do, a for loop, I go, oh, one-off BCD does exist. So then now I will basically union BCDE with ABCD. So that's basically the idea behind this beautiful 5 lines of code that speeds it up to at least 13% or something like that, maybe more. I don't know. I didn't do the math. I just did 13 times 13. I think that's the optimal, because that's if there's 13 characters and you remove 13 characters, and so that's basically the idea here that makes it AC. And then the rest is just kind of the loop. The rest is just like a for loop to get the best. This is this is basically a counter to get, okay, look, this is the parent, let's sum up the size of the component, right? And of course, if the size of this component is bigger than best, then you just update best. And that's pretty much the idea, and we return the answer. Yeah, so that's pretty much the idea. So what's the complexity, right? Well, for each word, we do at most 26 things. I mean, I know that we do each character, but that's going to be less than 26. This is going to be 26, and every operation here is O of 1. So that means that this is going to be O of 1. But O of 1 times 26, and this is this is O of n. So O of n iterations. So total time is going to be O of 26 times n, but again, there's a lot of optimizations, right? So you may have an O of n solution that is too slow. And you can maybe think about this as, instead of O of 26 times n, it's O of u times n, where u is the size of the universe, which is 26. And a slower one that I did, for example, would be this, and this is too slow, right? It is too slow. And in terms of spaces, it's going to be O of n, because in the well, you have the union fine here. Scene will be at most O of n, and one off will be at most O of n. Yeah, and this is also O of n at most, because if they're all disjoint, for example, in time and space. So yeah, I'll show you my code quickly, very quickly. This is union fine. This is just initiating the stuff. This is the meat of the code, if you ask me. And then, yeah, this is basically just going through all the groups and then just counting them and returning the max size. Cool. That's all I have for this one. Let me know what you think. Let me know what you find. You could watch me suffer live during the contest. Next. Pending interview. Okay, there we go. Okay. A lot of silly mistakes, but we're here. Q4. Let's go. So edit distance of 1. One or more non-intersecting groups connected. Okay, so isn't this just union fine in a way, but you have a big thing? Suppose no one got it yet, but I don't know what the answer is, but let's see. So let's see. Length is 26. Oh, no letter occur more than once in. Okay, so that's the big one. I actually missed some of this because this is not, or maybe it's in there, I don't know. Okay, so that means that we use a bit mask lookup, I suppose. Yeah, okay, that's not so bad. Right. Okay, this is where people would say maybe you should have a template for this, and I'll be like, yeah, okay, I hate you too. Because I think that's the benefit of having a template, is that I can focus on the problem instead of focusing on getting this right, which is very easy to get wrong by accident. Okay. So now, oops. Let's see. should do the same thing I did earlier. What's my heater thing? It's very cold here, so I have a heater thing, but it gotta shut off a little bit. I don't know if you could hear it. Okay. So then now we try all possibilities. Yeah, okay. Okay, scene.add_mask. And now we try, okay, adding one, right? For I6. If, let's see, if this is equal to 0, then we can do this, or we can add one. Was it again replacing one letter with any other letter? So okay, that's fine too. That's I don't know about the complexity though. That's like 26 square. Maybe. Don't know. Yeah, maybe 13 square. So 169 times this number. I don't know if it's gonna be too slow, to be honest, but only one way to find out. Okay, so if it's not in, I mean, if it's in there, take it out, or if it's not in there, put it in. If it's in there, take it out. And then if and mask and scene, then we union mask and mask. I think that should be okay. Yeah, okay. And then also I don't want to keep track of these numbers. No, I guess they're all in scene, so it's fine. Okay. And then now we want to say proof. This last one is annoying, but it's also fine maybe. One letter from the set of the letters, one including itself. So they could be connected if they have identical words. Like, can this, is this routed input? I guess I could sit and wait, but okay. The replacing one is a tricky one. Oh, whoops. Doesn't matter, right? But, okay, because if they not have to be unique, then they have to be connected, and then the size gets different. I think that's the annoying one. Okay, that means that. Okay, that means that this has to be a dictionary, I guess. Okay, and then now we have to do a replace. That's fine, we already assumed that they're in the same group. So we don't have to do anything funky, but we should do the replace. This is so annoying. So negative indexes. Is that how that works? Okay, they're not in there then. Okay. Mask, you want to take off this, and then you want to put on this. Like I said, I don't know if this is fast enough. I mean, this should be fast enough if I didn't do it in Python, but in Python, I guess I never know. Okay, so then now this is good. And now we can do for, okay, for keys, not keys. G is G define a key. C not key, okay, and then just return G dot the length of G and also the biggest one, right? So okay. Can't type today. All right. Okay, so that looks right. Whether this is fast enough, we'll see. How did people do? Are people done? Yeah, people should be done, right? I don't think Q4 is impossible. But it might, I don't know if this times out. Oh, did I mess up the, maybe I messed it up. Well, this is just a silly thing, but why it should be, oh, typo, no, Larry, no. No. Oh no, that is a silly mistake. I mean, wait, this is still wrong, so fix it, Larry. Okay, so oh no, so and I put in the wrong place anyway. But oh no, I test this, but then I forgot that I didn't test the replacement one. Okay, that was that. Oh no. How many people have solved this so far? This looks a little bit weird. Because we saw a lot more people solve, right? Maybe they took away the Chinese servers in this update ranking for now. Okay, time limit exceeded. That makes sense. I don't know how to do the exchange one though. I feel like the other stuff should be fast enough, but this one, I'm not sure. 13 square. Should I have done this in not Python? Do I give up on Python or do I try to optimize my Python? I don't know. Yeah, let's do it in C++. Was it 2 times what, 13 times 13? That's only 3.3 million. Should be fast enough. I think it's a Python thing. That makes me sad then. Okay, so then now, and this is also where having a union file library would be super helpful. But Celery. This is so sad. I don't know if this is fast enough even, to be honest, but it's not slower. I know that. That actually was very quick to yeah, I don't know. I guess it's just this, right? So maybe I don't need it. I am wondering if I'm missing something really obvious though, to be honest. But I just want to make sure that this compiles really quick. This might not compile though, but that's fine. Okay. Okay, so that actually works. Okay, well, compiles. I knew that. I mean, I was worried that it wasn't going to be fast enough, and turns out I was right. And I had a typo. That's, well, not typo. Just a bug, which is actually pretty sad. See if that works. Just for now, make sure that compiles. So now we did all this. Oh yeah, I mean, there's some minor optimizations we can do here with only using, but I feel like that's a very tail end optimization. So I don't know. Did I do that wrong? Maybe no. I think it should be right. I don't think this is. I don't think this is should matter. Unless I have a typo. And if this is too slow, I don't know how to do it. Maybe. No compile errors. That's good. One again for compile. At least it's right. It's just time limit exceeded. So it is what it is. I forget how to do iterate and map. At least for each. Okay. I always forget this actually. Well, I haven't done C++ enough. Oh, nope, the other one scene. I guess that's really it, right? Yep, you're right. I didn't cast this to int. Okay, that looks okay. Let's see if that's fast enough. I don't know. A lot of people got this. I mean, I'm not surprised. Well, like 24. I guess that's not. I mean, more people probably didn't update yet. If this times out, I don't know what to do. Okay, I don't know what to do. Let's see if this is just this case or. I mean, that's the trouble, right? I hope I click on one code and not submit because I think it's just this part. If not, then I don't know. Okay, now my computer's a little bit slow. How do I do the swap one then, if not this? Replace exactly one letter with another letter. I think I have a way of doing it, but this is so slow. But I don't know how to do it quite in a good way. I think it's because I'm sending a lot of stuff on this test case. I mean, this is fast enough. It's just the sum of execution time things again, which is actually kind of sad. Because there's so many groups. I feel like I have a way to do it, but six minus one. Okay, fine. How many people got it so far? Yeah, okay. Am I going to try in Python again? Maybe I can. Let's see. I'm curious whether this even runs. But it actually runs out of time in a hidden case instead of a given case, so that's a little bit sad. Actually, that took a while too. Let's say if I remove this, would that be fast enough? So I was at 1.4 seconds. And that took 1 second, so we can definitely do some, so that could be a thing. So let's say we do this instead. This obviously doesn't have the right code, but I think this is just this actually. But I wanted to see whether if I optimized it to this, it would be fast enough. But okay, so then now, what is the right answer here? I just want to put it into a place so that I can use it later. Okay, let's just put it here. I don't know. Okay. Okay, so we could get rid of this by having a. Is equal to. Okay, I don't care about this. Okay, so if this is this, then I can do. So this is the removal. If and mask in one of, then union mask one of and mask else one of and mask is equal to mask. Okay. See if that works. I was wrong about the C++ thing though. N indices with N indices. Okay. Bye bye, Felicia. Okay, so this is much faster and it is still the right answer. So let's give it a submit. Hopefully it is good enough. Not quite sure. I mean, I don't know how to do it if this isn't fast enough, to be honest. Please, okay, that's not that bad. I mean, that's a good optimization actually, but yeah, that's gonna cost me a lot of time. I don't know. It took me a long time to. I mean, there's so much penalty on this because of the Python uncertainty, right? Like I paid the Python tax here because I probably could have gotten this optimization, but I wasn't sure that like I just didn't C++, but like I spent I don't know how long time. Let's see, because I end up spending 10 minutes in C++ plus a penalty. So that's about 15 minutes of this time. So that means that if you minus 15, then it's like what, 41? 41 would have been I don't know, maybe top 50, right? But now I had to. I wasn't sure that C++ wasn't good enough, and I had to do I have to do the optimization in Python, which is not that bad. But I mean, it took me some time to think about it, and I thought about it while I was doing the C++ one. Probably didn't take me 5 minutes, but I think I was maybe talking about it a little bit and expositioning it a little bit. But I don't know. I mean, I think that's the issue with this one for me anyway, is that I did pay the Python tax of uncertain it'll be fast enough. I actually could have also done it in C++, but at that point, maybe there's additional uncertainty, but yeah, thanks for watching. Hit the like button, hit the subscribe button. Join me on Discord, especially if you like talking about these contest forums. Hope you did well, and let me know about what you think about this forum. Stay good, stay healthy. To comment down. Good. No, okay. Stay good, stay healthy. To good mental health. I'll see you later. Bye bye.